Welcome to 2018 higher level paper. This is question B3. It's an intersecting planes question. So the image on the right shows a piece of roadside sculpture. In the form of a steel hedgehog, which is located on the M11 in County Wexford. It comprises of a series of planar surfaces carefully aligned to allow for water runoff, for the runoff of rainwater. Okay, so there's our kind of hedgehog. Figure B3 shows the plan elevation of 4 such intersecting surfaces. So we've got our 4 intersecting surfaces here. The horizon line and vertical coordinates for points A, B, C, D, E and G, so not F, are given to us here. Defining the 4 planes are also given to us here. Draw the given elevation and plan of ABC, so ABC and ABDE, so ABDE, so just those 2 planes for part A. Okay, we'll start off by locating all of my points. So remember, we're going to go out, up, and down. So for this question, I'll come down a decent amount and set space on my XY line. Okay. So start my starting point here. I'm going to go 1, 4, 5 to A, 2, 10 to B. C is 1, 5, 5, 1, 3, 5, point D, 100, then to E and G. Okay, now my vertical measurements and horizontal, measurements up and down. So just line up my 10 millimeters there. It tends to be quicker. So we're going to go up 60 at A. So at A, up 60. Actually, show a projection line between them. So that's A. And then down 45. So that's down to 55. That's A. And B, we're going up 35 and down 80. C is 100. And it's down 75. D is up 10 and down 105. Up 10, down 105. E then, we got up 45 and down 60. And G up 125 Okay, so I'll start off just by drawing my ABC and ABDE. ABC. As I'm doing this, I'm just looking at the solution here, making sure that I'm not drawing heavy lines where I'm going to need to draw dashed lines or hidden detail lines. So that's ABC, and now ABDE. So ABD. So there we have the elevation plan of those intersecting planes. Next, determine the dihedral angle between ABC and ABDE. So AB is the shared line, so that's the line of intersection between them. So what I need to do is I need to find the true length of AB, and once I have the true length, I want to look along the true length of that AB line to see it as a point view. So I'm going to take an auxiliary elevation looking directly at AB first of all. So using sliding set squares here, I'm going to draw an XY line here, or X1, Y1. Now project out all of those points. So X1, Y1. Okay, so I'm creating an auxiliary elevation here. I know it's an auxiliary elevation because I'm projecting from plane. Right? Because of that, it's an auxiliary elevation. Okay, or because of it being an auxiliary elevation, I'm going to take my heights from the elevation. Right? So let's start off here with, we'll go with the largest one first. So C, and work my way down there. So let's see, follow it down C and down to A. Now you equally could take these measurements from your question sheet because those vertical heights were given to you. So there's A, E, B, and finally D. I know it's 10, I'm just going to measure 10 just to show you it will still work. Okay, so let's index all of those up. So I got C, B, A, E, and D. Okay, so AB being my important line, that is now a true length line of that. Let's draw my planes, ABC. And ABDE. Okay, so this is a true length line. Right. Once I have that true length, I'm going to look out along it. So, setting my set square there, slide it out. I'll draw my x2, y2. We'll project out all of these points then. Okay, so I've got my x2, y2. Okay, we are trying to find a point view of AB. Okay, so when I step off a distance here, it should be A and B should be found on the same point. Okay, they should be the same distance from my xy. Okay, and a quick way to learn is to go back 2 views. So we're going to go back 2 views from my x1, y1 back. Okay, or if you want to think about it this way, that the distance from A to my x1, y1 is the same as the distance from B to my x1, y1. So we know that that distance for B and A, when I step it off here, will put A and B on top of each other. So that's the quickest way, or the easiest way to remember it, to guarantee you won't make any mistakes. So distance from B to the x1, y1, I'm going to follow B out, and I know that's going to be the same distance for A. So that's my A and B both found there. Let's go to find point C, back to the same x1, y1, follow C, point C, and then point E, point E out, and finally point D, which should give us the same, something in line with there, so we got E, D. Okay, so my point view of AB is found there. There's my AC. Okay, so that's my point view of AB. So this is my dihedral angle. Okay, in the question, determine the dihedral angle. Right, they didn't say determine the measure, but we always will keep a good habit of measuring that angle. So let's measure that. For me, it's coming out at an angle of 101 degrees. Okay, so 101 degrees. Okay, so back to my question sheet. Dihedral angle, we found that. Next up, they want us to draw the elevation and plan of point G and determine the distance between G and B. So G, we still haven't drawn there, so we'll draw the elevation and plan of G, and it joins and creates a surface. You see? Read the question fully. Draw the elevation and plan of point G. Determine the distance between G and B. Between G and B. Okay, so that's something that's coming later. The opposite edges E, AE, and the GF are on the surface parallel. Okay, so first off, we'll start with, I've got my G here. Got G here. And I want us to find the distance between those 2 points. So they essentially want us to find the true length between those 2 points. So I'm going to draw the line that we're looking for first off. G to B, that's the line we're looking for. So let's find it here. So they want us to find the true length of that line. We have two options for that. I can take an auxiliary, so x1, y1, and take my distances from my elevation, because it's an auxiliary elevation. Or a quicker way is, I'm actually going to, if you imagine this is my line BG, just trying to line it up, I'm going to rotate it around so that now when I look in at that in elevation, I'll have found the true length of it. So let's rotate that. So G to B. So B won't change its level, so that is the true length. Just put a little colour on that to show it. Determine the distance between them, side that. True length of BG. Okay? Just showing an arrow rotating that around and projecting up. Right, so that's the first part of C. The opposite edges AE and GF, so AE and G to F, so G to F, they're telling us of the surface AEGF are parallel. So they want us to draw this surface AEGF, AEGF. Okay, they're telling us that AE and GF are parallel, so AE is parallel to GF, parallel, parallel. We know from our key principles of graphics that parallel lines appear parallel in all orthographic views. So I can draw a parallel line to A, E from G. We know that E and F are directly in line with each other, or vertically aligned. So I will project F is going to be somewhere up there. And sliding set squares. Here is GF. Okay, and I can join G back to A. And AE, parallel again. Let's locate F there and F there. And join G up and okay, so that's my plane completed. Okay, so there's a few little bits in this. Complete the elevation and plan of surfaces A, E, G, F, or FG, we've done, and ACG, ACG. So I just need to draw an ACG. ACG. Okay, now I've found CG, I can actually come back and I'll put in my hidden detail line. That section between A and B. Okay, and that's part C correct, or completed. Determine the projections of a horizontal line from C. So a horizontal line from C will appear as a horizontal line here, like that, from C, which will touch plane AEFG. So AEFG is going to touch it at a point which is 55 millimeters from C. Okay, so first off, let's draw that horizontal line, which will be in line with F. Draw my horizontal line. Okay. I'm actually going to extend that because I want to see where we're essentially taking a horizontal cutting plane in line with C that goes through this plane AEFG. Okay, so it's going to create a line on that plane. Okay, and I'll call that F1. Now I'm going to locate that line in my plan. So, point 1, project it down onto line GA. There, that's my point 1. And here is the projections of that line. Alright, so now the next stipulation in that question, right, we have a horizontal line drawn in line with C. Great. So we've essentially created a plane here from C, and they want us to be, we're going to find a point that touches the plane which is 55 from C. So that's a horizontal plane, it's a true shape. Okay, so I just need to find, that's where it intersects the plane horizontally. Yeah, so I just need to get my compass, set it to a radius of 55. And from C, swing an arc, and that'll find our point. So let's call that point X. Alright, and I'll show that projects down. And we want to find projections of that point, I'm sure, so let's project it back up to my elevation. So that's going to be point X again. Okay, so the point is found there. Now, hence determine and indicate in degrees the true angle between the horizontal line and the vertical plane. So, we need to draw that line. Sorry, I forgot to draw that line. So, that line, I'll use my different colour here. That's the point where it crosses it. That's the line. It's a horizontal line, and we want to find its angle with the horizontal plane. So check that on, and the angle with the horizontal plane, then we measure it here. About 53 degrees. Okay, so 53 degrees. Okay, because that's my vertical plane there. Okay, and that is that question complete. So we've got a good bit in that. Okay, we've got true or the dihedral angle, true length of a line, horizontal cutting plane, and an angle between a line and the vertical plane. Okay, so nice, interesting question there. It's a nice one to practice.